show proof, the simplest quaternion is already in that question itself. Meaning, you just let S equals to I and C equals to J or Q. You know that? Because if you take I times J, you will get I times J, you will get, let's say I times J, you will get A. But J times I, you will get negative A. Try to do that. Just let S and C be any of that. This is to prove that commutative law of multiplication is not satisfied in quaternion. And then in order to prove that, because we want to show something that is not satisfied. Because if you want to show something that is positive like that, something positive like it is satisfied, then you have to do it generally, the proving. But this is something that you want to show that it does not satisfy. You can just use a counter example. Okay, so just take as maybe I, J, okay, and then C is one of them. You cannot take one because there is identity, and later you will see that if we say that X times 1 will be equal to 1 times X. So just consider I, J, and K to be any of the X or K. Okay. If Rajin, you can see all of I times J, J times K, okay? K times I. But just for this question, just let S will equal to I and then C equals to J or K. Okay. Counter example to this. So to verify this is just a practice for you also to do the multiplication for S on quaternion. Okay. And then for this quaternion, this is statistic. Okay. This statistic, the quaternion does not satisfy commutative law of multiplication, and meaning that if we denote it by H, then this H is not Papian. It is not Papian plane because Papian plane Upper theorem satisfies commutative law of multiplication. Okay? So this quaternion is actually a non-Papian plane. Can you see whiteboard? I'm sharing my screen now. So, if you recall in chapter 6, we have purpose. And this purpose actually is like result theorem. And this purpose has commutative. And here, does not obey the commutative law of multiplication. So, if we have some plane that satisfy results, okay, but it does not satisfy purpose. Okay, first it satisfy now. So, put it satisfy result and it satisfy purpose, then it is a Papian plane. Then what if we have result but purpose? No such thing. Because purpose should imply result. If it is purpose, then it should be also result. Okay? But if it is result but not purpose, then it is called non-Papian plane. Non-Papian plane. Non-Papian lah. So the example is the quaternion projective. Okay. Why? Because if we say that result is satisfied in this HP2, because in this HP2 quaternion, in this quaternion, AB is not equal to BA, and meaning the computation in result also this AB not BA, so the computation related to multiplicative commutative is not required. Why is not required? Because even in this result itself, it satisfies all the field axioms except the commutative law of multiplication. Except the commutative law of multiplication. So because in result condition, we no need this commutative law of multiplication, and since this quaternion projective plane is also not commutative multiplication, then it essentially still satisfy the result theorem. But because it does not satisfy purpose, because purpose satisfy all field axioms including the commutative. But in this, not commutative. Okay. So number 6. Let's number 6. Explain why the distributive law. Okay, so this distributive law is the last field axiom. Okay, if we recall in chapter 6, we just proved the first distributive law. Okay, this last thing, this one, and there is actually another form of distributive law. One in a plane, for a plane. Okay. Why the distributive law inside the other distributive law in a partial plane? Okay, we know that partial plane satisfy all field axioms. I will not write this, this is take note. Partial plane satisfies all field axioms, including the commutative law of multiplication. So because we know that this partial plane satisfies that commutative law, therefore, the other distributive law we can obtain from this B plus 2 times A. It is actually A times B plus C. This commutativity. Kan? And then we know that this equals to AB plus AC. And then because of that commutative law again, we have BA, AB equals to BA, and then AC equals to 2A. So we obtain this left hand side of the distributive law equals to this right hand side of distributive law. That is why. Okay. So you are using by commutative law B plus C plus A is equal to A times B plus C. And then by this first distributive law, we know that we have this form. And then again by the commutative law of multiplication, AB is equal to A, and then AC is equal to A. So we obtain this left hand side equals to this right hand side. This is partial plane constitution because partial satisfy the commutative law of multiplication. Okay, because in some terms with non-commutative multiplication, such as the quaternion,
lapar
but we cannot prove like the one in partial, we can use the commutative property. In distributive law, in quaternion, a system with non-commutative multiplication, both distributive laws remain valid. Why? Why both distributive laws are valid for the quaternion? Because the quaternion can be defined using a metric system. Remember that complete metric system is this metric system. Okay. So this metric system actually generally it specifies the distributive law. So even though the quaternion does not satisfy commutative law of multiplication, it satisfies the distributive law because in general, metric systems satisfy both distributive laws. That is the relation. Okay? Then you can show that both distributive laws are valid for matrices. This one you can find in because it is just division. Okay, to be distributive laws for matrices. Okay, you just need to show this one. Okay, so that's all for tutorial. Now tutorial 7. Did you all do tutorial 7? Is anyone there? Quickly is the lesson. So disconnected. Okay, doctor. Okay, tutorial 7. Anyone with the first answer? Is ABCD is a quadrilateral. Is that the midpoint of each side? Typo ni. The midpoint of each side form a parallelogram whose diagonals meet at the centroid of its resistance of the quadrilateral resistance. Is this true for quadrilateral in R3 also? So this is true. This also should be true for R3 because it is just string. Okay, R3 is a string and R3 is a string. Okay, so we have to make sure that the midpoint of the quadrilateral will form a parallelogram. Midpoint
Long copian plane on a copian.
So what do we have? We have a quadrilateral ABCD. So we can take that this ABCD. Let's say first we have a triangle.
Ah? Woohoo! Nasi goreng sudah siap.
Okay.
Kelaparan, tahap kelaparan
Then the reflection on line B. So we have the quadrilateral ABCD. So a line joining the midpoint, we know that because a quadrilateral can be divided into two triangles like this. And if we have a line, let's say a line joining the midpoint. This is the midpoint of two sides of triangle is parallel to the third side. Okay? So we also have another parallel. This is mid. Okay? So this point, this midpoint, form a parallelogram. parallelogram where these two sides are parallel, and these two should also be parallel, and the diagonals of the parallelogram meet at the centroid, meaning centroid of the
Bismillahirrahmanirrahim.
quadrilateral. Okay. The centroid of the parallelogram is actually the centroid of the ABCD. What is centroid? Centroid ni apa tak? Centroid is, did you learn on centroid? We have learned in chapter 3 first. Recall what is centroid, anyone? Anyone? What is centroid? Lah, laptop depan mata, Google je, cepat Google. Google. Centroid. Itulah, centroid is the geometric center of the figure. Okay? Geometric center. Okay? Or we say that it is an arithmetic mean position of all the points in the figure. If we have the diagonal, meaning the diagonals of the figure should also meet at the centroid. Or we say that centroid is the median of any plane figure passing through the same point. Okay, so that is centroid. So we want to show that this we already showed the midpoint of the sides of quadrilateral forms this blue parallelogram. Okay, meet at the centroid. But how to put in words? So we have to take that line.
Dapat pandang bos dah.
So a line joining the midpoint of two sides of a triangle is parallel to the third side. What's the quadrilateral? Ini sama tak? A line joining the midpoint of the two sides, say the SAAB and BAB, the midpoint is this line connecting these two midpoints is parallel to the third side. Okay? And the pair of sides are parallel. Okay? Similarly also the other pair, the midpoint of BC and BD forming a line that is parallel also to BD. Right. So we have the centroid of the quadrilateral centroid? The centroid of the quadrilateral is, what is the centroid of the quadrilateral? We have 1/4 times A plus B plus C plus D. Okay. The centroid of a triangle, meaning 1/3 times A times B times D. But this is a quadrilateral, so we have 1/4. Okay. This is the constant for the quadrilateral that we have to compare with the parallelogram form, and we also have to check whether the parallelogram has the same centroid, because we said just now the midpoint form a parallelogram whose diagonals meet at the centroid of the vertical. Okay, so what is the centroid of the parallelogram? The centroid of the parallelogram is, so what point we have? This first point is A plus C/2, right? Betul tak? And then the second point is B plus C/2. Kan? Kita syok sendiri ni, betul ke? B plus C over 2.
Saya rasa betul. Saya rasa
Logik kan? Okay.
logik lah tu ni.
So 1/4 is 2A plus 2B plus 2C plus 2D over 2. Then because we can cancel the 2, factorize the 2, cancel with this one. So we obtain the centroid of the quadrilateral, to be A plus B plus C plus D. So when is the centroid? This is actually the centroid of quadrilateral. Over. And this should be also true for quadrilateral in R3. Because a quadrilateral in R3 is still also a quadrilateral. And the point ABCD is can be preserved in perfection. Okay, so number 2, if AB and A prime B prime are two line segments, prove that there are two similarity transformations that map like this. Okay, for this one, you will have to consider square with AB and A prime B prime. With this, we have to consider the square AB, okay, and also the mapping AB, where the first one is the direct mapping. Direct is AB, 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 C, D. And then here it will be AB, this is the direct mapping, and this is the opposite mapping. So we take a square ABCD on the line segment AB, and two possible squares. What are the squares? A, B, C, D, and so similarity transformation is a transformation that makes square a square. Okay, meaning if you have a square, then it still makes to another square. So because it makes square to square, there is actually a unique assignment. There is a unique assignment taking triangle ABC to triangle B prime, B prime, C prime. And another and these two are the required pair of similarity. So we want to prove there are two similarity transformations. So we already left because similarity should make square to square, then there should be unique affine map that takes the triangle ABC, so this ABC is preserved under the affine map, and so we know that there is enough mapping for it to be similarity transformation. So number 3, let F be the element F. Find the order of F in the projective group. Okay. Projective group, this projective GL2R is just actually a notation, don't be scared of it. Okay. It stands for projective linear group, where if we composite two elements, meaning we multiply the element, okay, and it consists of elements in the form of functions, like the one you see there, f equals to x plus 3 over 3x minus a, and then if we multiply two elements, meaning we composite the functions f, okay, and we can represent it using matrix A, B, C. So in order to answer this, we can use matrix multiplication. Okay? And we have to, because I think that in chapter 7, we see that A, B, C, D is actually equal to B. Then you will have to see how, when you multiply 2f, meaning f squared, namanya a, b, c, d times a, b, c, d, how many it has to times until you get something, and that something actually the order of f, order of the element. group theory. You don't learn group theory. You learn I think in further linear algebra. In further linear algebra or modern algebra. You learn that if you multiply the elements and then you obtain the identity, kan? So in this case, we will obtain 1001. Then this is the order of the elements. But you have to remember, because this is projective, okay? This is projective linear group. That projectivity, okay? You may find that the identity, you can find this form of identity, but there is something in front here. Okay? Do you do this? What is the order of F? Anyone? The order of F is 2. Okay, good, Rashida. Okay. Try to multiply the two composite it, or maybe you just use the matrix and you find that the order of F equals to 2. Okay, prove that F has 2 fixed points, and the 2 fixed points is actually equidistant from F infinity. Anyone want to share answer? Do you know how to do this? Anyone get this? Anyone can prove that for points P and Q, and P from F infinity and Q from F infinity have same distance. Okay. A point, we have a point X, that X is a fixed point. A point X is a fixed point if X equals AX plus B over CX plus B, and try to express X in the form of only A, B, C, D. Okay? Because if we recall, if we have a cross ratio, remember the cross ratio involving 4 points, and then it can form, okay, D is 4 points. So because this X is reserved under the 4 points A, B, C, D, so it is a fixed point. Then just express X only in the form of A, B, C, D. Okay? If we continue to rearrange the terms, then we have X is X plus B equal to AX plus C. Okay? So CX squared plus BX silap lah. X. So F ni only minus A silap It should be minus A. Ya, kacang tak boleh kacang. So this is minus A. This is minus A. Okay. So CX squared minus 2AX minus B equals to 0. So how to know what is X? This is solving quadratic equations punya formula. Continue this, you will obtain X is actually equal to A plus minus method, a squared plus b over c. Then we just let point P. See this already. This is actually x is actually 2 fixed points. Let's say let P is a plus, okay, this one, and then q is actually a minus. Okay, so we already have this. We can write this like a plus c. A over c. See, this P and Q is equidistant from A plus C by this distance. Meaning if we have point A over C, then distance A squared plus B forward, we have P, and then we have negative A squared plus C, we have Q. This A plus C is actually at infinity. Okay? So we conclude hence F has 6 points. What are the points? P and Q. That is equidistant A over C. A over C is actually F infinity. Why? Okay. You all okay? F infinity is a x plus 3 over x a over x, and then a plus okay, a plus b over x over b minus a over x, and then x approaching infinity, this is actually a over n. So we find that eventually when we let a point x to be fixed, and when we express x in the form of only a, b, c, okay, and actually 4 points where this is actually negative a, we see that this p is the point plus a distance and this point minus a distance, and this point is actually from as infinity. It just follows that. And number 4, so that the midpoint. Oh, number 4 ni yang saya bagi dalam kelas. Show that the midpoint of any line segment is preserved by linear transformation and hence by affine transformation. And then for number 5, it is actually the generalization of number 4. Because number 4 we use only midpoint. But this one, if that line has a certain ratio of lines, meaning it is not divided equally, so does that line still preserved by affine transformation? Yes, it's still preserved. So we have to show, you can show this by using what do you use? The distance. the distance between points. The midpoint punya formula. So we want midpoint of any line segment. So we want to see what is the midpoint. So we can represent the midpoint by, let's say, P and Q. And then how this P and Q is still preserved even though it undergo an affine transformation. So it's a affine transformation at x equals to x plus 2. Okay. So let's say let x let 2 points. X2, Y2, the endpoint, of a line segment. Okay, first we let this. Okay, then this line segment should have midpoint. Okay, if we have midpoint, then let's say the midpoint is Q. Okay, then this midpoint is actually x1 plus x2 over 2, and then y1 plus y2 over 2. Kan? Itu basic ni dalam math dulu. Okay. Now, after a linear transformation, let's say this transformation, meaning each point x undergo this transformation. So we have say x1 prime, y1 prime, meaning fx1, did we get at fx1 is still x1 prime? Did we get x1 prime? It's actually ax1 plus b. That is equal to fx1 equal to, if fx1, then the image should be this one. So fx1 is ax1 plus b, and then ay1 plus b. And also we have the under transformation f, 2y2 under transformation f, we obtain this one. So we denote this point under transformation to be x prime dengan y prime. Okay. Then we have if we transform the midpoint also. Now midpoint, what is the midpoint of this? Okay. Now midpoint of the new transformation would be P prime, Q prime, x1 prime plus x2 prime over 2, and then y1 prime plus y2 prime over 2. Okay. So we want to see whether this midpoint is actually will be equal to the midpoint of the original point, the points of the line segment, the first line segment, whether it is preserved. Okay. So if you continue to do this, you should obtain a P1 plus B and a P A Q. AP plus B and AQ plus 1. And this is actually is transformation of point PQ, right? That is so AQ plus B, AQ plus B. So since we already obtained that the midpoint is actually the transformation of the first midpoint,
Oh, lah.
okay, thus we have
Habis tu nak suruh apa? Dia tu nak cakap, suruh buat apa lagi? Mau ni lah.
and hence the midpoints are preserved. Midpoint P and Q is preserved by the linear transformation. And it is an affine transformation. Okay. Okay. For number what number? For number 5, the ratio of length. Okay, if you see here PQ, we have this one, right? We have midpoint, this one. But if that line segment, if you have line segment, ratio here, okay, let's say that this is PQ, okay, and then this is X1, Y1, and this ratio, let's say it is N and N, then point PQ actually is nx1 plus nx2 over n plus and ny1 plus ny2 over n plus. You can find the coefficient by yourself. Okay, how you obtain this. It's similar to something if you construct a triangle. Something like this is the hypotenuse of a triangle. Okay, so somehow you obtain this formula. So by using this formula, check whether this point is preserved under transformation M, where you will obtain this also. Okay. For number 6, if F is an affine, this one you will see that the affine, the centroid, you let this as point. Never mind, this one we discuss next week. Okay. So complete the proof for number 4 and 5 because it is important. Okay. So that's all for today's class. ramai ni. Ni kot, diorang ni kot, story lawan banjir kot. Okay, that's all for today. Thank you everyone. Thank you everyone. Welcome. See you next week.
Thank you, Doctor.
Okay. Welcome. You all come. Beria, Hanani, Wishida, Gawira, Pesta, Atisa, Ito, Hanu, and Doshi. Okay.